Hey guys, we're going to talk about triangle sum theorem, looking at interior angles of a triangle and also looking at the exterior angles of a triangle formed by one of the sides that are extended and also its adjacent side. And we're going to talk about how to find the value of those exterior angles as well as how to find the sums of the interior angles. So we're going to begin with what's called the triangle sum theorem. So the theorem states that the sum of the interior angles of a triangle add up to equal 180 degrees. All right, real simple. So if I'm looking at this triangle, you see angle A, angle B, and angle C. These are all interior angles. All right? They're inside the triangle. So the theorem states if I add A, B, and C together, they'll equal 180 degrees. So I'm going to just show you guys real quick what that means. So let's say this is 87. This is 47. So let's say we need to find this angle C. And they've given us 87 and 47. So what I want to do is I want to add those two together, 87 plus 47. And that's going to equal 134. Well, if I know that all together they equal 180 degrees, I'm then going to take that 134 and subtract it from 180. 180 minus 134 equals 46. So the measurement of this angle, angle C, would be 46 degrees based on the triangle sum theorem. So real simple, the interior angles of a triangle, when you add them all together, they equal 180 degrees. The second theorem that we're going to look at is on the exterior angle. Well, this exterior angle is equal to what we call the sum of its remote interior angles. So this is its adjacent angle. The remote interior angles are the two angles that are non-adjacent to the exterior angle. So that would be angle B and angle A. So this angle, let's call it D, would be equal to A plus B. So we're going to do a couple examples and show you exactly how that works. I'm not going to use the green because I know the green doesn't show up that great. So let's say we're looking at triangle sum theorems. We're looking at the interior angles of a triangle. So let's say this was 2x. This was 2x, and this was x. So what we would do is I'm going to add them together. 2, 4, 5, 2x plus 2x plus x. Well, again, what does that equal? Well, we said that equals 180 degrees, so equals 180. So I'm going to add all my like terms together, 2x, 2x, and x is 5x equals 180. Inverse operations, divide by 5, divide by 5. X equals 180 divided by 5, 3. So in this case, x would be 36 degrees. So what I'm going to do then is I'm going to take that value, 36, and I'm going to input it into the functions inside the triangle. This is 1x, so that's 36. This is 2x, so it's 2 times 36, 72, 72. So that's how we would do it if they're giving us different values instead of whole numbers. If they're giving us functions, you'll add up the functions together, set it equal to 180, and then add like terms, and then use inverse operations to solve, which we've been doing before. You can see that again in the parallel lines cut by a transversal video that we did earlier last week. So again, just another simple angle. All right, so I have an exterior angle. Exterior angle, here's my triangle, it's my exterior angle. So if this is 40 and this is 25, we stated that angle D equals the sum of the two remote interior angles, B and A. So D equals 25 plus 40. So in this instance, D would be 60. So this angle would be equal to 60 degrees. So again, let's say they gave us some functions instead of whole numbers. Let's look at another one. We'll do one more. So I have this triangle here. So let's say that this was 2x plus 6. Actually, let's give it a different value. So let's say that that was 4x plus 20. And let's say that these two angles, x plus 25. And let's say that this last one here was x plus 20. We'll make this 2x plus 25. So we stated that this angle is equivalent to these two angles. So I'm going to write the function that we set that up. 4x plus 20 equals 2x plus 25 plus x plus 20. So I've taken the exterior angle and I've set it equal to the interior angles added together, right? The sum of the interior angles. So I'm going to use combining my like terms. So I'm going to combine 2x and x. That's going to give me 3x. And then I'm going to add 25 and 20. And that's going to give me 45. Again, that's going to be equal to 4x plus 20. So I'm going to use inverse operations. I'm going to always move the smaller x to the other side. So instead of moving 4x over here and creating a negative number, I'm going to move the 3x to that side so I can still work with positives. I'm going to subtract the exact value. Inverse is exact opposite. So if I have a positive 3x, I'm going to subtract 3x. They'll cancel each other out, minus 3x. I'm going to write down what's left. 4x minus 3x is x plus 20 equals 45. Well, I need to get x by itself, so I have one more step. This is a positive 20, so I'm going to subtract 20. Those cancel each other out. Write down what's remaining. X equals 25. So you can see here that in this situation, the value of x is equivalent to 25. So the last step, the last thing I need to do is I'm going to input that value back into the functions to solve for the angles. So this angle, x plus 20, 25 plus 20. This angle would be 45. This angle, 2x plus 25, 2 times 25 plus 25, 2 times 25 plus 25, 75. Well, I know these two added together equal this, but let's just check. 25, 4 times 25 plus 20, 100 plus 20, 120. So if I add 75 and 45 together, does that equal 120? Well, let's check. 5 and 5 is 10. 1 and 7 is 8 plus 4 is 12. 120, 120. All right. So again, that's how you're going to use the triangle sum theorem in the exterior angle theorem, as well as the exterior angle is equal to the sum of its two remote interior angles, to find the missing angles either with whole numbers or with functions. All right, piece of cake. All right, good luck, guys.